Okay, now we have completed the introduction where we just kind of thought about what is a solution, the difference between an inequality and an equation, that we have to be careful with inequalities when we're solving. Let's put it into practice. So number one here says y is greater than 1/3 x minus 5. Is that in slope-intercept form? Yes. Okay, we're good. Now I can graph it. Now I start at -5, so 1, 2, 3, 4, 5. I'm going to go ahead and put a point here. My directions say up 1 over 3. Up 1 over 3, 1, 2, 3. Up 1 over 3, 1, 2, 3. I'm just trying to get to where when I make my line, I'm going to be as accurate as possible. Remember, it's always best, if possible, to go in both directions when we are creating graphs by hand. We want to be as accurate as possible, so I'm going to go ahead and pull out the ruler here. And before I draw this line, I need to determine, is this a solid line or a dotted line? And I do so by looking at my symbol. I have greater than, so it's not equal to. Thinking back, remember when we talked about the difference between equal to and not equal to? It's sort of like playing that old game of they're not touching me. They're not touching me, or I am not, you know what I mean, right? Well, that means if it's only greater than or less than, it's all the way to it, but not actually touching it. So then I'm going to use a dotted or a dashed line to represent. Remember, our line should have arrows indicating it goes on forever. And then I need to determine, am I going to be above or below this line? Are all of my solutions greater than or less than? And I look there and it says greater than. So because this is greater than, I'm going to shade. You don't need to shade very dark. I'm just going to say, well, then all of my solutions are above this line. And that means I could pick any of those coordinates. I could pick this coordinate. Yes, that's a solution. I could pick this coordinate. Yes, solution. This one, it wouldn't matter if it was above. Those are all solutions to this inequality. All right, number 2. Y is less than or equal to -2x minus 1. I'm already in slope-intercept form, which is great. I'm going to start at, -1. My directions say -2, so -2 over 1, right? So I can move down 2 over 1, down 2 over 1, and I could keep going in that pattern. I can go up 2, back 1. Just trying to get as much on here as I can so that my line is nice and neat when I do draw it. Now, am I drawing a solid line or a dotted line? Yeah, this is equal to, so this is actually touching this line. So I'm going to go ahead and create an actual solid line, like you would normally draw a line. And now I have to determine, am I going to shade to the above or shade to the below? Now I look here, it's less than, so I would shade below. One way of thinking about this is if I started here at my y-intercept, I want to shade the side that is below my y-intercept. So below would be this direction, so that tells me that I would shade this side. And all of these coordinates I'm shading over are solutions to this equation, including all of the coordinates that actually land on the line. All right, number 3, 5x minus 2y is greater than 12. As we're working here, I should say you should just be pausing this video and moving through at your own pace. Don't try to work backwards. Stop, draw it out, and then move to the next one. 5x minus 2y is greater than 12. We are not in slope-intercept. So the first thing you want to do is get into slope-intercept. I'm going to subtract 5x from both sides. So now I have -2y is greater than -5x plus 12. Divide both sides because I have this negative. I'm the mathematician dividing by a negative. Remember, I'm going to circle my symbol so I remember that's got to flip. Then I'm going to divide everybody by -2. So y is now less than, that's a negative and a negative, so positive 5/2 x, positive 12 divided by -2 would be -6. Okay, start at -6. And then my directions say I go up 5 over 2. I'm going to put at least 2 on here. I want to make it as straight as possible. Dotted or straight. Yep, that is a dotted. It's not equal to. It's the I'm not touching you line. As close as I possibly can be, but not actually touching the line. And it says less than. So I'm going to go back to my y-intercept. I'm going to move down, and then I would shade everything on this side of the line. And all of those shaded spots or those coordinates, everything underneath the shade is my solution. I could pick any of them, plug it back in, and it would be true. All right, so for the next ones, what I want you to do, so I want you to pause the video. I want you to work it into y equals mx plus b, and then I want you to graph. This is a good time to say again, in math we use pencils, so you can erase, especially when graphing and using shades. Don't shade something in real dark until you're sure you know exactly where you want to be. So just make a little line, double check, and then shade it in. Just a helpful tip. So again, number 4, go ahead and put that into y equals mx plus b, double check, then we'll graph the line and shade. All right, there's my equation. Y is greater than 1/4 x minus 2. I want to remind you, flip that sign, be careful. It's a good practice, just circle it as soon as you see it, and then keep working, that way you don't forget. And you know, sometimes we still get kind of caught up on that x. Remember, there's a 1 in front of that x, so if it helps when you're working with fractions, go ahead and write that 1 in so you see it, and that will remind you that you have a fraction there and that 4 does stay in the denominator. So let's go ahead and graph this. Remember, you need to start at your y-intercept, move, make several points, and then you'll need to determine, how do I connect it? All right, so here is my line. It is dashed or dotted because it does not actually touch the line. And I'm thinking greater than, right? So greater than. So just to be sure I'm going the right direction, if I went back to my y-intercept and I moved up, then I would be shading everything on this side of my line. Okay, try out number 5 and number 6, and then let's talk about number 7 and number 8. All right, so double check 5 and 6. Remember number 5, we had to flip the symbol when we were solving. And then on number 6, well, we didn't. So it's about you as a mathematician. It's what you tell the problem to do. If you tell it to divide by negative, you flip the symbol. So again, you're in charge here. Number 6, the trick was you had to remember that that 0 for that constant means that you're going to start at the origin. So number 7 says I have y is less than or equal to -4. So here we just have y. X is not there. So do you remember back to equations when we just have y and there's not an x? We had a way of remembering that. Yeah, hoy. So at hoy, that tells me, that's a horizontal line, and I have a slope of 0, so it's going side to side. There's that -4. -4 is where I am on the y-intercept. And then I'm going to draw a horizontal line. Now, is this a solid or a dotted? We're still playing the same rules. Is it solid or dotted? Equal to, so it's solid. So I'm going to go ahead, make a solid line. Less than. That says less than. It's pointing out the y, less than. So less than would be this direction. So everything underneath. Number 8. X is greater than 7. There's no y, just x. So we're back to that VUX. Vertical line, undefined slope, and x equals. So I'm at 7. So I'm going to go take my x to my x-intercept. And then I have a vertical line, solid, or was it dotted? Is it dashed? Yeah, this isn't touching 7. It's everything up to 7, then not actually 7. So I'm going to line it up. But this is a dashed line. And it says x is greater than 7. X is greater than 7. Well, then that would be 8, 9, 10. So that'd be everything to the right. So y equals mx plus b first, always. Make sure you solve carefully. And then, just like before, graph your intercept, follow your directions, determine, is it touching the line or is it just going to the line? And then shade, is it greater than or is it less than? So that you can get all of the coordinates. You're showing all of the possibilities that could happen for this line.